So good morning, students. So today we are going to discuss the non-operational attributes of an embedded system. So yesterday we have discussed about operational attributes of an embedded system. So today we'll discuss about the non-operational, right? So we'll go to the next slide here, right? So what are these non-operational attributes? Okay, so non-operational attributes basically doesn't tell about the functioning of the embedded system. So basically they discuss before the embedded system has been launched in operation, what are the other attributes you have to take care of, right? So the one I discussed, the operational attributes, they basically speaks about the functioning of the embedded system. So we have discussed throughput, right? Reactive, okay. So there are many other those attributes we have already discussed in the last class, right? So this non-operational, basically they tell before designing of the system, what are the other attributes you have to take care of. So the first one is the testability and debuggability, evolvability, portability, time to prototype and market, per unit, and the total cost. So there are 5 quality attributes will be discussed today, right? So first we will see the testability and debuggability. What is testability, right? So before, like if you are launching the product in the market, that embedded system, first it should be tested, right? So how the testing is done? It is done with respect to the hardware and the firmware. The firmware basically tells about the software. For any embedded system, there are both the components will be there, hardware as well as the software. In the software, you will be writing the coding with respect to that particular embedded system. So here you can be using C or C++, embedded C or assembly language coding for the embedded system design, right? So here the testability, it has to happen with respect to both hardware and the firmware. Firmware concerns about the coding you have written with respect to the processor. So first, before that, you have to do the testing. Is there any errors are there in both the hardware level and the software level? Then what is the debuggability? Debuggability is nothing but first you have found out the errors, then you have to do the debugging of that, right? So the best example, like if you're writing a programming in Turbo C, you have an option called debugging there, right? Step-by-step execution is there. There are debugging tools are there in the compiler, right? So you can find out the error, where the error is there in the software, and you can debug it. So debuggability talks about correcting the errors in the total system or the embedded system design. So that is debuggability has to be done with respect to the hardware as well as the firmware. So firmware is nothing but the coding program that you have written with respect to the embedded system. So this design concept you have to think of before launching your product into the market. This is one attribute you have to think of before you put the product into the market, right? What is the next one? Evolvability. Evolvability basically tells about there is a term related to the biology, right? So here, how it related to the embedded system is, right? So whenever you are launching a product or the embedded system, what you have designed into the market, there will be a change in technology also. So right, like you have used a processor, ARM controller, suppose assume that you have used ARM controller. Again, there is a new version of ARM controller or the microcontroller will come into market. So with respect to that, your product should be able to do the modification in that. So that also care you have to take in the designing aspect also. And also with respect to the hardware technologies. So some of the sensors, the new sensors, maybe some changes in the designing will come into picture. So that time, whatever the embedded system you have designed, it should be able to adapt to the new hardware technology as well as the software. So that is what is the evolvability. So this also you have to take into consideration whenever you are launching your product in the market. That will come under the non-operational quality attribute, right? Then what is a portability, right? So portability is nothing but the embedded system what you have designed, it should be running on all the operating system, right? It should run on all the operating systems. Suppose the C is, if you have written the coding in embedded C, that means this coding what you have used in embedded system, it will run on all the operating system. But some of the coding, it will not support on the operating system. So that also care you have to take into designing aspect. It should be flexible and portable. Portable means it should run on different operating system also. It is not only to the operating system, even the processor what you are using, right? Suppose the new processor comes into market, and if you want to change that into your embedded system, that also should be editable in your embedded system. That is, you should be flexible and portable, right? So portability is nothing but a system independence. It should run on all the platform. That is what is the portability, right? The next one is time to prototype and the market. What is time to prototype? The time to prototype is nothing but before designing, you have to do the layout of your embedded system design. So what all the sensor you are using, what is a microcontroller, which bus configuration you are using, all those designing should be done before you are designing the product and you are launching it into the market. Why it has to be taken care here is because when you launch into the market, suppose a new technology has entered into the market, and if your product what you are launching into the market, if it doesn't fit into the new technology, then you fail here, right? So product prototyping, suppose the new technology is coming into the market, that also should be model or the layout should be done in your designing, so that when you are launching in the market, suppose a technology has also entered, then what should be done immediately at that point, that should also be thought of. So product prototyping is nothing but building a layout of your design, the draft copy of your design, so that is suitable to the market. That it should be done before only when you have designed an embedded system and you are putting it into the market. If you are too late, then there is a failure in your product design, and again you have to go for the new designing that you have to apply in the embedded system, right? So the next one is the per unit cost and the revenue. So what this basically tells about, this we will try to understand with the graph here, right? So basically this indicates the product life cycle, that is the PLC curve, right? So what this PLC it is telling, suppose assume that there are n number of cell phone manufacturers are there here, right? Assume that the one company has wanted to launch the mobile, right? So basically this product life cycle basically tells when he has to change his model design, right? Suppose he has designed a 4G mobile into the market. So immediately what period, after what period he has to change his product, or then he has to apply the new design technology, that basically is seen in this graph. So here they are telling you about the revenue versus the time. The revenue is nothing but the income that what they are getting for the company who is manufactured that embedded system. So this is the product development. In this period, what happened? They have done their product, right? Now what happens? At that time, they will do the market analysis, right? And they will decide what should be the unit cost of their product, right? They will analysis, they will do what should be put it into the market. So they will put the unit cost. Assume that the cell phone mobile, they have thought of giving the 4G mobile, right? So about assume that 10,000, right? So they have put it into the market. At that time, you can see the product sales, the sales of the company start increasing, right? That means their product is developing, it is gaining a good revenue or the income, right? And the graph is going like this. At the same time, they're also earning the profit. That means at this time, there are no competitors with them, so that they can change their technology. At this period, they are only the competitor in the market who is selling that product, and their revenue is also increasing and the profit is also increasing. Now, at one point you see here, the graph has reached the maturity. That means at that point, there are other cell phone manufacturers have come into picture. They have also designed the 4G mobile at the same features what this company has designed. At that time, what happens? Their product sales, when it has reached to the maturity, it goes on decreasing. That means they have reached the maturity. That means what? There is a one more competitor who has come into the market. Therefore, they are not getting the product sales, and also their profit is getting decreased here, right? At this point, what they should do? They should stop marketing their product, because there are n number of competitors who are come into the picture, and therefore they have to go for the new technology, and they should design with the changes in the 4G mobile, and then they should come into the market. This is called the product retirement. That means there are n more than competitors are there in the market with the same model they have come, and therefore their profit is also getting decreased, and they have to reduce their unit cost. At this point, they have to change their product design or come up with a new some technology, and then again launch. So this is one non-operational attribute which you have to think into picture, that is per unit cost and the revenue. So whenever you are putting, not only you have designed the embedded system, when you are putting it to the market, you have to do the market analysis. What should be the unit cost, and when you have to change the product design, that should be done analysis before only, right? Otherwise, it is not going to be a growth in their product design. So these are the non-operational quality attributes, right? So there will be one question on this. What are the non-operational attributes of an embedded system? So one thing you understand, this basically doesn't tell about the functioning of the embedded system, how they work, whether they are working. You have seen in the operational attributes, that is when they are working, they should quickly respond, their efficiency should go good. That all attributes we have taken, but here non-operational attributes are the one which are not related to the functioning of the embedded system. Basically, they are telling about other attributes, that when you have designed your product, what are the care should be taken. You have to do the testability and debuggability. Otherwise, there is a chance of your product should be failure in the market. And evolvability, you have to remember, any new technology comes, your product should be able to change the technology in the embedded system design. And portability is what? It should run on all the operating system, and whichever the new processor or the sensors come into the market, it should be flexible and portable. It should be changeable. It should adapt to all the environments or the components that are coming into the market. The time to prototype and the market, you remember here. Here it is. Before putting into the market, study all the technologies that are coming into the market, and according to that you do the layout of your designing, and don't do the delay in establishing the product in the market. So that attribute should be taken care of. And also you have to study the per unit and the total cost. That means the income, how much income you are going to earn based on the total cost, right? And when the product should be changed at the market, all this analysis should be done before you are launching the product into the market. So basically the non-operational attributes talks about that before the embedded system is put into the operation or put it into the market, right? What other care should be taken? So these are the 5 parameters. So there will be one question on this, about 8 to 10 marks. What are the non-operational attributes of an embedded system, right? So we'll go to the next topic. And again, there will be one question on this also. That is, we already see that the characteristics of an embedded system, each of the embedded system is designed with respect to one application point, like a washing machine. The application here is it has to wash only the clothes. You have just seen it, but you don't know what is there inside the washing machine and how it operates. So that designing how it is done. So one example you are going to learn with respect to one application and one domain specific, right? So first we will see the washing machine, right? So you all know that the washing machine is used for washing the clothes, but you don't know what is there inside the washing machine, right? So here this embedded system consists of sensors, actuators, control unit, and application specific user interface. So this I have discussed in the third module. What are the embedded system components? They are having sensors. Sensors are nothing but what? They will sense the inputs based on the physical environment. Just like suppose in the air conditioning system, there is a temperature sensor will be there, right, which will sense the surrounding temperature. Based on that, it will control the room temperature. So sensors are sensing the input variables, and based that it will convert it into a electrical signal. Actuators, sensors are the input device sides, they will come. Actuators are the output devices. Basically they will control the output, right? Based on the electrical signal, they will produce a particular output with respect to the whatever the input they get from the sensor. And the control unit is nothing but it will control all the sensors, actuators. Here it will be having the microcontroller and bus configuration. Everything will come into picture. And what is the application specific? So with respect to the designing, it goes like how the keyboard designing you want, how the display devices should be there. Again, in the mobile you have a different application specific user interface. You have a keyboard layout, right? You have a touch screen. Like that, the display unit differs depending upon the embedded system what you are thinking of, right? So based on that, so how the washing machine is designed, what is there inside it, right? So we will try to understand with this with the help of the diagram here, right? So I just want you to go through this diagram here. This is a washing machine, right? So there will be one question on this. Explain application specific washing machine with an example. That time you have to draw this diagram, right? So you all have seen the washing machine, right? So here this washing machine, it contains a tub. There are two tubs are there. One is the inner tub, this is you see, and this is one is the outer tub. So in the inner tub you will be putting the cloths. And what are these holes? The holes are nothing but whenever you dry the clothes, that time it has to take out all the water from the tub. Therefore these holes are there. And this in between, this what you see, this is called agitator. Agitator is nothing but a motor which will, when you put the cloths, right, so that time the motor will start either rotating, it will rotate in both the direction, clockwise and anti-clockwise. So this is acting as a motor which will wash the clothes. It will rub the clothes so that whatever the soil particles are there, it will come out, right? So this is the main part in the embedded in the washing machine. Other than that, you have a water inlet pipe. So here, because you need a water to wash the clothes, so here there is a water inlet pipe is there, right? And water outlet. So after washing the clothes, it has to drain all the water, the dirty water. So that time there is a water outlet is there. Other than, you can see in the diagram, there are sensors. Where these sensors are located? So here you can see there is a one sensor which is located, is called the temperature sensor, and one sensor is the level sensor. Why the sensors are required? Whenever you put the cloths inside the washing machine, there has to be temperature has to be set. Suppose if you are washing a delicate clothes, there will be a hot water washing will be there. That time this sensor will sense the temperature. According to that, what happens, the temperature will be set either with the cold or the hot. This sensor will help in setting the whatever the user has set the temperature settings, right? And the level sensor is basically how much water should be kept in the clothing. It is not that you have to full, it has to be there depending upon the load or the weight, that water has to be maintained in the washing machine. So this sensor will help in sensing the level of the water, right? So there are two sensors are there, level sensor and the temperature sensor. Basically they help in setting whatever the user sets the settings, right? So that setting you can see here. You have a, this is called the keyboard. So you must have, all of you people are having a washing machine, right? So whenever you are putting the clothes inside the washing machine, so either you can keep it with the different settings. You have a heavy setting, you want to only soak, or you want to do only the rinse. Either you want to do 30 minutes washing or 2-hour washing, or the delicate clothes washing. Depending upon this, these two sensors will work here, right? And then coming to here, you must be thinking where the microcontroller interface is there. You can see on the top, there is an integrated control panel. This is there at the back side, that is not visible, right? In the control panel, what are all there? There are microcontroller unit, and there will be some bus configuration and coding. Everything will be written in that microcontroller, the processor. It may be a small chip which is there at the back side of this here. It is not shown in the diagram here, right? So here, this control panel, it will be controlling whatever the inputs that are given by the customer or the user, right? So here, again, where are the actuators are located? See here, the actuators are nothing but, here it is acting as a water inlet pipe and water outlet pipe. These two are acting as the actuator. Actuator means they will control the inputs whatever given by the user. The user will say, okay, he will put the cloths inside and he will put the only for rinsing, right? That time what happens, this sensor will sense, okay, only the user has put the rinse. And also in the user interface, you can see here the LED display. This is used for what? It has to show the timing here, right? See, whatever the timing is shown. Suppose for the rinsing, it may take 30 minutes. So that timing, it is shown here. So in the user interfaces, you are having the LED display. Also, like the keyboard interfaces will be there, which the user can press here, right? So when you put, the user has put, assume that only in the rinse mode, that time the timing will be shown here. At the same time, the control panel will take care of controlling the whole unit. How it is done? With the help of actuators and the sensor, and there is only not the hardware unit, there is also the programming is written. Most of this embedded program, they are done with the C here, right? So whenever the cloths are put, what happens? The water level is sensed, right? Suppose it is put for the rinse, automatically the programming is done, right? How much water should be kept, that sensor will do that. And what is the temperature of the water should be done, this sensor will sense. According to that, it will be done in the tub. And what this agitator will do, it will rotate either in the clockwise or the anti-clockwise. And at the same time, what this actuator will do, so when you press the start button, that time the water will enter into this pipe. At the same time, the water outlet will take care of, after when all the cloths are washed out, it has to do the actuator. Actuator means it has to drain all the water from the washing machine. So water outlet and water inlet pipe and motor, these are all acting as the actuator here, right? So this is how the washing machine works. You must have seen outside, but you have to see here how it works inside. So there are not only the hardware components are involved, there are even the hardware in the main components. You have a sensors, actuators, and the control panel. The control panel, you are having the microcontroller board, and also you are having the certain user interface where the LED display is there and the keyboard, right? So this is what the washing machine, right? Okay, so this there will be one question on this, right? The question that will be asked on this is, explain application specific embedded system washing machine with an example. It will be asked about 10 marks, right? So here what you have to do, you have to draw the diagram neatly, okay? And then you explain how it works with the help of the sensors, actuators, control unit, and what are the application specific user interface. With respect to that, you have to explain this concept, right? So today we have learned the two concepts in our today's class. The first one is non-operational attributes, which is very important in the designing concept. Before launching the product, what are the things you have to take care of? And one example we have seen already, the product has been designed. So how it is designed? So what are the inputs, sensors, actuators, and the microcontroller, how it is used in the system, right? So today I'll just conclude here, right? So we'll have a interaction about 10 minutes on this.